Hey, today we are going to learn to use ratios to determine if two figures are similar. So, similar figures have the same shape but not necessarily the same size. When we write about similar figures, we always name the vertices, which are the points of figures, in the same order so that we can compare them. So similar figures have sides that are matching, and those are called corresponding sides. So if we look in this picture, for example, we have corresponding sides and corresponding angles. AC, which is this side right here in this triangle, corresponds with DF. And we could write that as AC corresponds with DF. And in similar figures, we're going to have a definition for it in a second. You'll know what happens between corresponding sides. Any corresponding sides in similar figures are proportional. So you can write a proportion. AC is to DF. We've got to pick a different side over here. We can say BC. Well, the side that corresponds with BC is EF. So AC is to BC the way that DF is to EF. And then we can solve a proportion, which we already know how to solve proportions, if we were maybe missing what the side length of one of those was. Also notice that in corresponding angles, 82 corresponds with 82, 43 corresponds with 43, and 55 corresponds with 55. The corresponding angles, the matching angles, are equal. So let's look at that definition that we just kind of talked about anyways, and I want you to write this definition down in your notes. Let me get rid of this. Two figures are similar if the measures of their corresponding angles are equal and the ratios of their lengths of corresponding sides are proportional. So write this down, pause this, and write this down in your notes. Okay, let's look at an example. Determining whether two triangles are similar. So identify the corresponding sides in the pair of triangles, then use ratios to determine whether the triangles are similar. So we've got to pick which sides in this triangle do we think are corresponding. Well, if we look at it, point B is across from here the way that point E is across from there. So this one is actually color-coded. Whoops. So this should be pretty obvious for this one. But AC right here actually corresponds with the side DF. We know that because the point is across, B is across from here, and E is across from here. You can tell that those points match. So we know the angles B and E were corresponding because you can tell by the way that they're across from that side. That's how we knew AC correspond with the DF. That means that DE corresponds with AB and BC corresponds with EF. So let's look at the way that that looks over here when we write it. It says AB corresponds to DE, BC corresponds to EF, and AC corresponds to DF. So when we write that as a ratio, using the corresponding sides, we have AB over DE. You know that because they correspond. BC over EF and AC over DF. So we have the small triangle on top compared to the big triangle on bottom. So just the way we set up our ratios before, small over big. To solve that, all we have to do is say, plug in the values 4 over 16, that's AB over DE, 7 over 28, and then simplify those ratios down. Since they all simplify to 1/4, we know that the triangles are similar. So these are the problems that you are going to solve on your own. This question 1, and then this question 2, whether these figures are similar. So you're going to have to answer questions about these two slides, whether these are similar and whether these are similar. So set up your proportions to see whether the side lengths are proportional. Thanks, and see you all tomorrow.